Okay, good evening. Welcome to
Math task number 13.
Math Task number 13. So I was talking on Twitter yesterday with our friend Dave Ratcliffe, and he mentioned something that would be really interesting for students to think about. It's a little abstract, so I'm gonna kind of walk you through it a little bit more. So we're not just looking at symbols here,
Yeah.
but we're going to look at a minus the quantity b minus c and a divided by the quantity b minus c. So first, before we dive into the symbols, let's look at some numbers first. So what if you were going to do 7 minus, let's say, 5 minus 2? What would you do here?
I would solve in here first. And
Okay,
then
so what does this equal?
that's 3.
Okay,
That would be 7. So that would be 4.
7 minus 3 is 4.
4.
Okay. Now, if I have it with symbols, though, I can't do that simplifying internally because b minus c, we don't know what that is.
Mm-hmm.
So can we do something with this negative sign here without actually doing the subtraction in the middle first and still somehow arrive at the number 4? What do you think happens?
Well, maybe we... Well, let's see. Maybe you can do 7 minus 5 plus 2.
Oh, okay. Why do you think that might work?
Well, it's because you're subtracting b and then you're adding c again.
Okay. So why does that happen? Why do you subtract b and add c, do you think?
Well, because you have 2 minus signs. That will... And then 7 minus 5... The quantity and the parentheses... So, you want to do maybe 7 minus 5 first,
Uh-huh.
and you add 2 at the end.
Add 2 at the end, and so what does that equal to 4?
Yeah.
Okay, awesome. So what do you think a minus b minus c equals?
So a minus b plus c.
A minus b plus c. Interesting. And now let's take a look at division here. If I was going to ask you to do, I'll just use the same numbers. 7 divided by 5, what was it, 5 and 2?
Yeah.
7 divided by 5 halves. What would you do there?
Well, I would kind of flip it over, and then that turns to multiply.
Okay.
So you have 7 times 5, 2 fifths.
7 times 2 fifths. All right.
And then that's 14 fifths.
14 fifths. And then what do you think a divided by b over c is?
So that would be a times c over b.
A times c over b. Okay. So this is what Dave's question was. What's similar about these two situations? That a minus b minus c is a minus b plus c, and a divided by b minus c equals a times c over b. Why are those two situations similar to each other, do you think? And sorry to everybody listening for the dog slurping in the background. What do you think is similar about those situations?
Well, in both equations, you're kind of turning one of the function symbols into the other. So here, so you're turning a minus into a plus and a divide into a multiply.
Okay, that's interesting. So how are minus and plus related to divide and multiply?
Well, they're the two sets of those type of functions.
What do you mean?
So like plus and minus are one set, and multiplication and division are another set.
Okay, interesting. So somehow in the first one, the minus is turning into a plus.
Yep.
And in the second one, the divide is turning into a multiply.
Yep.
And then what happens once those turn into their opposites?
Well, it kind of goes from less to more. Because when you're dividing, you're splitting it into smaller groups, and then when you're multiplying, you're getting more of it.
Okay. And what about the minus and plus?
When you're subtracting, you're taking away some, and when you're adding, you are adding on some. So each time it gets larger, assuming you're with integers.
Interesting. Okay, cool. Well, that was fun to talk about. Good job, hon.